Okay, so everything is kind of new at some point. So at some point, people believed that the Bible was right about God having formed heaven and earth 6,000 years ago, Noah's Ark, the great flood, and so on and so forth. And then the geologists came along and said, no, 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 Earth is much older and we have evidence for it, and so on. And here I am telling you we are increasing greenhouse gases and Earth has a greenhouse effect, and so that's why Earth has a nice temperature, and the greenhouse effect on Venus makes it very, very, very hot, and so on and so forth. But did we already know about greenhouse effect for a long time? Or if not, who discovered it? We mentioned that Alfred Wegener started talking about continents moving, and James Hutton started talking about rocks moving around, and that Agassiz talked about ice ages, and so on and so forth. So, who then discovered the greenhouse? Well, there is a name already here, Joseph Fourier, from 1768 to 1830, was a physicist, and we are showing here different levels of greenhouses. If you had no greenhouse, then all the energy that was coming in, some would get reflected back because you would still have deserts and oceans and ice and so on, but all the energy would just stay in and go out. Whereas if you have a greenhouse blanket like this, then you have different dynamics. Energy coming in is not just going to go out, it's going to bounce around, exactly like why you have a blanket when you sleep, because you're going to trap the thermal energy coming from your own body. Your body is warm, maybe you don't feel it so much, but when you give your mom a hug you can feel it, or when you give your little sibling you feel it, and so on and so forth. At the beginning of the 19th century, the Frenchman Joseph Fourier, the French would, in English we say Joseph Fourier, but the French may be saying Joseph Fourier, was racking out his brains, trying very hard to work something out. He was how was it possible that Earth was not much colder than it is now? He took the size of the Earth and the distance from the Sun and played around with the numbers a little bit, because he was a physicist and he knew how to do all these calculations. So here he is trying to do some calculations. He calculated that it should be on average 15 degrees below zero on Earth. Took the energy, took the distance, and just said this is the energy coming in, and I do the energy balance and I get 15 degrees below zero on Earth. But it was almost 15 degrees above zero, and that could only mean that the Earth holds on to some of the heat of the Sun. It's not just sending it all back. Fourier had discovered the greenhouse effect. The atmosphere lets most of the rays of the Sun come through to Earth, but we know some of it gets reflected by the albedo. They only provide warmth when they hit the ground, the sun's rays, or your skin, because sun feels hot when you're out in the sun, or something else. If it's falling on a rock and you try to walk on a rock, it may feel very hot, so everything gets heated. You can see this on a nice winter's day when you're out of the wind. The air is very cold, but the sun on your skin still feels warm. This happens because some of the rays have turned into rays of heat, light and heat, right? And those rays don't get back out of the atmosphere as easily as the sun's rays entered, as it happens here. Shown here is no greenhouse effect. So sun's rays are coming in and they're going out, and the energy that is coming in is all just going out, which would make it very, very cold, right? So those rays don't get back out when you have a greenhouse effect very easily. The atmosphere works in the same way as the glass of a greenhouse or in a car or in a classroom, because it can get pretty hot inside, especially if you're sitting in India in the summer and sun is beaming, shining hot. There is no air conditioner and it's getting hot inside. Rays of sun come in through the windows, change into rays of heat and hang out for a while, heating things up. It was only 70 years later. Sorry, it was another 70 years before someone else picked up on Fourier's ideas again. Fourier discovered something, he said this is what is happening, and then people forgot about it. This was the Swedish physicist Svante Arrhenius. It was 1896 by now, and the poor guy was broken hearted. His marriage had hopelessly failed. So what do you do then if you are a brilliant scientist and your wife has said, I have had enough of you? You bury yourself in a mountain of numbers and you start calculating. Well, that's a bit of a simplistic statement, let's say, but anyway, it's just meant as a joke, right? So day and night you are crunching numbers and then you find something spectacular, if you are lucky, because sometimes you crunch numbers and you say nothing is happening. After a year, Arrhenius though got it. If there is half as much CO2 in the air, the temperature will drop by 5 degrees than what it was. That's enough to cause an ice age. If you cool the global temperatures or even local temperatures continuously by 5 degrees, then you would begin to build glaciers somewhere, right? So here is Svante Arrhenius, who lived from 1859 to 1927, was a good physicist, and you can see he's got his formulas, and for those who know, this is a relation between energy and carbon dioxide, and here he is cold, thinking about being cold without his wife, but then also thinking without CO2 we would be cold. So you can see a little teardrop here. We're imagining that he was sad after his divorce, right? But it also meant the opposite. If amount of CO2 doubles, then you would be increasing greenhouse gases and the temperature on Earth would rise by 5 degrees. Looking back, those figures are a bit extreme because Arrhenius didn't have all the facts at the time. He made an estimate with all the best science he had at the time, but Arrhenius was one of the first people to realize that by burning coal, factories could release as much CO2 into the air that it made the Earth warm up. This would further increase the greenhouse effect, so you could certainly call him the discoverer of our climate change. We said this about Agassiz before, who discovered ice ages. Now we are saying this about Arrhenius, but Agassiz was, let's say, talking about natural climate change, ice ages, and Svante Arrhenius was talking about people burning coal and increasing CO2. As an inhabitant of the chilly country of Sweden, Arrhenius didn't have any objections to this warming effect. By the way, he was proud that thanks to human activity, his children and grandchildren would have a milder climate in Sweden. In a warmer climate, Swedish farmers would be able to grow much more food. He was just worried that the change would take a long time, that we were not burning enough coal. Imagine, this is like the Doglanders when the sea level changed. They thought it's not a big deal. They were eating, other things than what they ate before, and said, we will manage, but then things got really bad. Svante Arrhenius also was not aware that if we kept burning fossil fuels, coal, gasoline, gas, and so on, we would increase greenhouse gases so much that everything would begin to become actually much worse. As far as he was concerned, we should be burning more coal, and we did, of course, but not because of what Svante Arrhenius said, but just because industrial revolution had started and we were just building more things. We wanted energy, we were running cars, we were running trains, planes came along, and everything started to be moved around by ships, and people moved, and we sold things, we built things, and we heated houses, and so on and so forth. And soon we were increasing the greenhouse effect of the Earth faster and faster, and we continue to do that even today. So Joseph Fourier and Svante Arrhenius are two key names to remember here. Before we had Hutton, and there are many, many names. We are just picking a few here. It's not just these few people who did everything, but you pick the key names along the history of the evolution of climate science and climate change, geology, and so on, to say what were the key steps in the process of making new discoveries and so on. So we'll come back and talk about the breadth of the earth. So CO2 coming in, CO2 going out of plants and people and life, and how the measurement started with Charles David Keeling. So we'll do that in the next podcast.